Eh, yo sí hablo español, pero mis amigos latinos me han dicho que no lo hablo ni muy bien español, y mis amigos americanos no me han dicho que no hablo muy bien inglés. So, me voy con inglés porque los términos que voy a utilizar, pues los conozco más en inglés. ¿Está bien? Eh, y by the way, yo he estado viendo aquí, ya la corbata está fuera de moda. Is ties out of fashion? Feel like, all right. So, I don't think I can introduce myself better than he did. Honestly, I feel like the word expert, I feel like Socrates, I just know that I know nothing. The more I learn, the more I feel like I don't know anything. But let's delve in the world of biological pesticides, or biopesticides, Dr. Lang said. And I'm going to try to say something about the role that toxicology and ecotoxicology play on these biopesticides. It's interesting because biopesticides normally have the uh how do you say that people think that I mean they're natural less toxic, but at the same time they need to go through these lenses from ecotox and toxicology for us to understand their impact not only to human health but also to the environment, and that's kind of what I'm here for. I'm gonna try to. Oh wait, sorry. Okay. All right. Um, so first of all, I'm just gonna briefly touch on what are biopesticides, and I think already a lot of people have talked about that. But so they're naturally um, occurred substances that come from living organisms such as animal, plants, fungi, viruses, bacteria, etc. I think the importance in sustainable agriculture it's been also touched on. Um, it has, I don't like to say advantages, but over chemical pesticides, but it is they're they're more targeted to, they can target species better. They produce less harm to non target species as well. They degrade faster in the environment and things of that nature. And so, like it's been said, it's a good alternative, for us as a pesticide to control pests, for pest management. Uh, so having said that, what is toxicology, right? So definition toxicology in essence would be like the adverse it's the adverse effects of chemicals on living organisms. Some of the toxicology scopes, it identifies, quantifies, and manage toxic substances to minimize risks to human health and the environment. For key sorry, like doing this, I'm trying. I can't read the here very well. And then key principles of toxicology, it includes dose-response relationships, kind of like how much of that dose it's produce adverse effects, exposure assessment, hazard identification. With hazard, you have levels of toxicity, acute, chronic, sublethal, lethal, and risk characterization. Methodologies of toxicology. There's a lot of animal testing, in vitro studies, computational modeling, and epidemiological investigations. Animal testing, there's a lot of studies that are done in mice, in rats. And then pesticide safety concerns, they play a crucial role in assessing the safety of pesticides, ensuring they do not harm non-target organisms or contaminate the environment. Ecotox. So this is ecotoxicology defines the study of toxic effects in ecological systems. So toxicology is more on the living organism, and ecotox is more on the what happens on the ecosystems. Some of the key principles is the mechanism of toxicity, exposure, and the exposure assessment that would guide mitigating strategies, like how to uh, how do you say application, what kind of equipment, things of that nature. Methodologies, they use acute toxicity tests, field studies that are employed in tox research, ecosystem impacts. They obviously the ecotox assesses the impact on ecosystems, including soil, water, and air. And biodiversity concerns. It examined the effects of how the chemicals affects diverse species and their habitats with these studies. Some of the benefits of tox studies in biopesticides, one of them is identifying potential hazards that would pinpoint potential risks associated with using pesticides. Again, this can be for biopesticides and chemical pesticides. So like dose, concentration, those kind of things are important to know before you, for instance, develop pesticide formulations. That would also go into that. It's one of the benefits of tox studies. More active ingredient, less the rates, pounds AI per acre, that kind of things. And regulatory compliance and market approval, understanding these impacts for meeting regulatory standards and going to market is obviously very important, not only for economical purposes for private industry, but also for public safety and for governments wanting to use these chemicals or countries wanting to use these chemicals. What is the intersection of toxicology and ecotoxicology with biopesticides? So like I mentioned, the way I say it is toxicology is more the tox that happens on the living organism. So how does it affect that living organism? And that you can so the mode of action, like how does the pesticide harm that living organism? What organs does it affect? And then ecotox is what happens once it gets into the ecosystem, right? How does it break down? How does it what species does it kill? Those kind of things. And so what's the bridge is real case studies. So here, knowing what's worked before and having a precedence of things that have worked, and using both of these sciences is the bridge to tox and ecotox. Tox assessment for biopesticides. So there's various testing methods or lab and field tests to determine effects on target and non-target organisms. Environmental safety, how does it affect, again, the soil, water, and air quality? I'm the right. And then the pathways, the routes that it takes to affect the organism or the ecosystem. So no, sorry. So it's the way the pesticide interact with the organism. Ecotoxic assessment on biological pesticides. This is what I was talking about on how it works on the ecosystem. So and some of the people already have talked about the fate and transport. How do they move through the environment and their persistence, effects on non-target organisms. How do these biopesticides impact the impact of biological pesticides on organisms other than the target species, pests? Methods, mitigation strategies for protection, how to safeguard the environment while utilizing this biological pest control, biodegradability assessment, how does the pesticide breaks down in the environment, tox testing protocols, standardized tests to determine the tox levels of biopesticides, and eco risk assessments to evaluate potential risks that poses to ecosystems and biodiversity. Some of the comparing biological chemical pesticides, I know I talked a little bit about it in the beginning, but it's mostly tox levels. There are fundamental differences in composition, environmental impact, and regulatory oversight. While these pesticides offer eco-friendly and target-specific solutions, chemical pesticides might raise sometimes more concerns about persistent residues and non-target effects. So compliance with these regulatory frameworks is essential to balance the effectiveness with the environmental safety. Future trends in tox and ecotox. Advancements in analytical methods, bioinformatic tools, molecular techniques are revolutionizing tox studies for biopesticides, enabling more precise assessments of tox and environmental impacts, predictive models, enhanced tox and ecotox predictions through advanced modeling for more accurate risk assessments, biotech integration, exploring synergies with biotech applications to drive efficiency and effectiveness in the research process, genomics integration, how genomic advancements are shaping the future of tox and ecotox research, regulatory impact, influence of emerging trends of pesticides approval processes, which I think is very important, indicating the need for updated regulatory frameworks. I'm going to show some of these frameworks. Pesticide registration requirements, guidelines, regulations governing the registration and approval process, including submission of data on efficacy, safety, and environmental fate. These studies sometimes are very expensive, and it's been my experience that the work of private industry and the government together in developing these studies for new innovative pesticides or these substances can be very beneficial for the country in general, for general use. Environmental risk assessments, potential risks to non-target organisms, including beneficial insects, wildlife, aquatic life, and potential impacts on soil and water ecosystems. Maximum residual limits, or MRLs, allowable residual levels of biopesticides on treated crops and commodities to ensure food safety and consumer protections. Labeling and advertising regulations. I can't highlight, how do you say this, enfatizar, stress this enough. One of the things I worked a lot with was a lot of these pesticides, their labels are in English. And normally, the people that are apply these, mostly from my experience in the US, a Spanish-speaking population. So most of the time, they don't know how to read these. They don't understand it. And so it's very important for governments and private industry to be able to target this to the people that are actually going to be applying this. And monitoring and enforcement, ongoing surveillance and enforcement mechanisms to ensure compliance with regulatory guidelines and standards for the use of biopesticides. Cost-benefit analysis. So obviously, like I said, a lot of these studies and getting this to the public, and an economic consideration needs to be made. A cost-benefit analysis can provide insights into the economic considerations, return on investment, and long-term benefits prioritizing environmental protection and sustainable pesticide use. Quantifying these factors will help stakeholders make informed decisions that would probably align with economic prosperity and with ecological sustainability. Global perspectives. This is a big one. Yeah, global collaboration is very, I think it's just in all our best interest to understand how other countries regulate their chemicals, their pesticides, what are they doing? Fostering collaborative initiatives to ensure safe and sustainable pesticide practices on a global scale by promoting cooperation, harmonization, stakeholders can better address regulatory complexities and promote responsible pesticide management across borders. I think we've talked about this quite a bit, but embrace sustainable pest control, integrated pest management. At the end of the day, we want what's best for us and for the environment, for the world. At the end of the day, we want to leave. I want to leave this place a better place, and I think it's very important that we start having a lot more conscious on that. And I think this is supporting research, adopting biopesticides not only by itself but as a combo for pest management practices that combine with other control methods, promote policies, advocate for policies that prioritize sustainable pest control practices benefits both the environment and public health, and embrace sustainability. Embracing sustainable pest control methods is crucial for long-term environmental preservation and human well-being. Some of the key takeaways, if you understood anything I said, biopesticides offer a sustainable and environmentally friendly alternative to chemical pesticides. It's not one or the other. It should both serve their purpose. Understand the role of tox and ecotox is crucial for the safe and effective use of these chemicals. Integrated pest management that combine biopesticides and other control methods, regular monitoring and assessment of environmental impacts are essential. And like Dr. Lang mentioned, continued research and innovation in tox and ecotox will drive the development of new biopesticides with improved efficacy and reduced environmental impacts. And that's it for me.